Today, I am taking the topic about rule-based expert system and model-based expert system. I am taking this topic. We know about the what is expert system. An expert system is a computer system emulating the decision-making ability of a human expert. Expert systems are designed to solve complex problems by reasoning through bodies of languages, knowledge, represented mainly if-then rules rather than the convolutional procedure codes. So this is expert system. We going about the first topic, rule-based expert system. A rule-based expert system is one in which knowledge base in the form of rules and facts. So that is knowledge is in the form of rules and fact is the most popular way in designing an expert system. It is also called production system. So the knowledge is represented in the form of a production rules. That is if-then rules. So the ability to use the experimented knowledge acquired from the human expert. We also already talk about it. Knowledge is in the form of heuristics. So we going to the architecture of the rule-based expert system. In this architecture, we see that a user state and expert system states. The user states we can see that input and output. Then the expert system as explanation modules, I/O interface, editor, inference engine, knowledge base, learning modules, case, history files, working memory. These are the components of the rule-based expert system. So we are moving to the components of rule-based expert system. The first component is knowledge base. This include a set of rules that encode the domain-specific knowledge. Each rule typically has an antecedent if part and a consequent part then part. So the knowledge base it consists of facts, figures, and their relationships, and it has two nodes for storing the knowledge, that is static and dynamic. In the case of statics, the facts are stored before the processing of the knowledge. In the case of dynamic, the knowledge gathered by online dialogues. This is knowledge base. Then a second component is inference engine. This is responsible for applying the rules from the knowledge base to the input data in order to reach conclusion or make decisions. So in the inference engine, they can accept input queries and then response to the questions, and it is uses both dynamic and static knowledge. In the inference engine, it's done by 3 steps. That 3 step is first one is match, second one is select, and third one is execute. In the case of match steps, the contents in the working memories is combined within the knowledge base. First of all, we combine the content in the working memory to the knowledge base. Then select. In the case of selecting state, the selecting the best rules. We going to the execute. In the case of execute, we selecting the best rule is executed. We have so many best rules. In that best rules, we taking the optimal best rules for executions. Then in this inference engine, there are backward chaining and forward chaining. First we talking about forward chaining. It's also known as data driven inference. So when the left side, that is if part of a sequence of a rules is instantiated first, then the rules are executed from the right to left. The process is called forward chaining. In the most of the case, most of the case or most of the problems are working in this manner, because we have a evidence to prove the we have the data, available data, and we have to conclude we have to conclude the solutions. uh, then we proceed by applying rules to fact and to produce the new facts, which are turn used by the rules to produce a new facts. This process continues until it generates a path that satisfies the goal conditions. Then we have a new data and we have a goal condition. We have to move in the fashion of forward, uh, data to goal. So the forward chaining is also known as data driven reasoning or goal driven reasoning. So this start with available data or facts and work towards a conclusion or goals. We have already First, we have already available data and facts. In that facts and data, we work towards and to go to the conclusion or goals. So, for example, we encourage students implies motivated students. So, we motivate student and healthy students implies worked hard student. Then, worked hard student and has goals student implies excel student. Finally, we get excel student implies succeeded students. This is the way of forward chaining. In this schematic diagram indicate the forward chaining. The direction of reasoning is in the data to the goal. We have a set of datas inputs and we have to go in the goal. Then that's about forward chaining. Then backward chaining. The backward chaining is also known as goal-driven inference. When a right-hand side then of the rules are instantiated first and left-hand side condition become sub-goals. So this working in the right to left directions or right to left movement. So these sub-goals may in terms scores sub-goals to be established and so on until the facts are found to match the lower sub-goal conditions. So this is working in the manner of backward direction. We have first we have a goal and that goal we have to go to the data. So backward chaining is also known as goal driven reasoning or backward reasoning. So we have begins with a goal or conclusion and work backwards to identify the evidence or data supporting to that goal. So we have a goals and conclusions, and that conclusion that and that goals we have to backward to identify the evidence or data supporting to that goals or conditions. That's about backward chaining. This is the schematic diagram of a backward chaining. We have first goal, then we have to go to the data. The direction of reasoning is in the backward directions. Then third component is knowledge acquisition. To create new rules for the addition to the knowledge base, we adding the new rules to the knowledge base, and we also delete the unwanted rules and modify the existing rules. The knowledge acquisition is also known as a editor. So, an intelligent editor can greatly simplify the process of building a knowledge base. We have to building a knowledge base. The intelligent editor is a greatly simplified process to build the knowledge base. So, this is the knowledge acquisition. Then next one is explanation modules. Explanation module. It provides the user with an explanation of a reasoning process when it is request. When a user is request what the explanation of the reasoning process, then the explanation module provide the user to explain the process of reasoning using the how and why queries. If the user does not agree with the reasoning steps presented, they may be changed using editor. So the user do not agree with the steps for reasoning. So in the knowledge acquisitions or editor can change the agree steps present in the reasoning. So this about the explanation modules. Then last component is user interface. This one of the interface to communicate the user and the expert system. So in this way, we have to put the input to the expert system, and we have to take the output to the output given by the expert system is done by use interface. So that's about components of uh, rule-based expert system. Oh, then we have a working memories. Working memories that is it hold the current state of system and information derived from the applying rules. That is about the working memory. So the advantages of rule-based expert system are it is easy to understand and interpret. Uh, then second one is it is well suited for problem with this clear rules and logic. Then we are going to our second topic, model based system. Model based system in AI refers to the computational approach that realize an explicit representation or model of the underlying problem domains. The model-based system use explicit module of the underlying process in a problem domain. So these models are designed to capture the essential features and relationship within the domain and allowing the system to reason, learn, and make decisions based on this knowledge. That is, this model represent the relationships and dependencies among different variables. These are model-based system. So we have components of uh, components of model based system. So we have a knowledge base. It contains model that represent the system understanding of the domain. So the system encapsulate the knowledge about the problem domains using the formal structures such as graph, rules, or mathematical equations. That is knowledge base. Then second one is inference engine. Uses the model to perform reasoning and make decisions. So this inference engine, the system uses its knowledge representation to draw conclusion, make inference, or solve problems. This is the inference engine. Then learning component. The learning component can adapt and update the models based on the new data or experiences. We have new data and experiences. In that basis, we can update and adapt the models. The system are often the capability to adapt and improve over time through this learning components. This learning process involves updating or refining the underlying models based on new data or experiences, and also enhance the system performance and adaptability. This is the learning component. Then go to the flexibility and adaptability. This explicit representation of knowledge allow model-based system to more flexible and adaptable to change in the problem domains. We can change in the problem domains. The flexibility and the adaptability is the explicit representation of knowledge-based system to change the problem domains. So problem solving. The model-based system are well suited for problem-solving tasks. as they can simulate scenarios, explore potential solutions, and evaluate the consequences of different actions using their internal models. So the problem solving is the well suit uh, for model-based systems. So it explore the potential solutions and simulate scenarios and evaluate the consequences of different actions using the internal modules. These are the problem solvings. Then and then uh, advantages of model based system. It can handle uncertainty and incomplete information better than rule based system. So it is more adaptable to change in the environment or knowledge. This is the advantages of model based system. So I am concluding my topic. Today I am taking about the rule based system, rule based expert system, and model based system. The rule based system, the system that uses a collection of if then rules to make decisions or solve problems. So these rules are typically derived from knowledge of a human experts in a particular components, and we are discussing about the components of the rule based system. Then then second part we have to take the model based system. The model-based systems uses explicit modules for underlining processes in a problem domain. This model represents the relationship and the dependency among the different variables. Then we also discuss about the components of model-based system. Then that's about my topic. So thank you.